On this episode of AI Adventures, we will attempt to go through an entire machine learning workflow in one video, pulling best practices from our previous episodes. It's a bit of material, but I think we can do it. Training a model with the MNIST dataset is often considered the hello world of machine learning. But that's been done many times over, and unfortunately, just because a model does well on MNIST is not necessarily predictive of high performance with other datasets, especially since most image data we have today are more complex than handwritten digits. Zalando decided it was time to make MNIST fashionable again and recently released a dataset called Fashion MNIST. It's the exact same format as the regular MNIST, except the data is in the form of pictures of various clothing types, shoes, bags. It's still across 10 categories though, and the images are still 28 by 28 pixels. So let's train a model to detect which type of clothing is being shown. We'll start by building a linear classifier, as usual, and see how we do. And we'll use TensorFlow's estimator framework to make our code easy to write and easy to maintain. As a reminder, we'll first load in the data, create our classifier, and then run the training and evaluation. We'll also make some predictions directly from our local model. Let's start by creating our model. We'll flatten that dataset from being 28 by 28 to 1 by 784 pixels and make a feature column called pixels. This is analogous to our flower features from episode 3, plain and simple estimators. Next, we'll create our linear classifier. We can have 10 different possible classes to label instead of the 3 that we used previously with the iris flowers. To run our training, we'll need to set up our dataset and input function. TensorFlow has a built-in utility to accept a NumPy array and generate an input function right from that. So let's take advantage of it. We'll load in our dataset using the input data module. I've already downloaded the dataset to a folder, so we'll point to that here. Now we can call classifier.train to bring together our classifier, the input function, and the dataset. Finally, we run an evaluation step to see how our model did. When we use the classic MNIST dataset, this linear model typically gets about 91% accuracy. However, Fashion MNIST is a considerably more complex dataset, and we can only really achieve an accuracy in the low 80s, and sometimes even lower than that. So, how can we do better? As we learned in episode 6, let's go deep. Swapping in the DNN classifier is a one-line change, and we can now rerun our training and evaluation to see if our deep neural network can perform any better than the linear one. And as we discussed in episode 5, we should bring up TensorBoard to take a look at these two models' performance side by side. It looks like the deep network could definitely use some more time to train though. Estimators makes this easy. All we need to do is rerun the call to the train and evaluate functions. Looking at TensorBoard, it seems like my deep model is performing no better than my linear one did. This is perhaps an opportunity, however, to tune some of my hyperparameters, like we talked about in episode 2. Maybe my model needs to be larger to accommodate the complexity of this dataset, or perhaps my learning rate needs to be lowered. Experimenting with these parameters a bit, we can finally break through and achieve a higher overall accuracy than our linear model can obtain. It takes quite a bit more training, but ultimately, this is worth it to achieve those higher accuracy numbers. Notice also that the linear model plateaus earlier than the deep network. Because deep networks are often more complex than linear ones, they can take longer to train. And at this stage, say we're happy with our model. We'd be able to export it and produce a scalable Fashion MNIST classifier API. You can see episode 4 for more details on how to do that. Let's also take a quick peek at how you can make predictions using estimators. In large part, it looks just like how we called train and evaluate. That's one of the great things about estimators, the consistent interface. Notice that this time, we've specified a batch size of 1, num epochs of 1, and shuffle as false. This is because we want the predictions to go one by one, making predictions through all the data and preserving that order. I've extracted 5 images from the middle of the evaluation dataset for us to try some predictions on. And I picked these 5 not just because they were in the middle, but because my model managed to get 2 of them wrong. Both were supposed to be shirts, but the model thought that the third example was a bag and the fifth example was a coat incorrectly. And you can see, looking at these images, how these examples are more challenging than handwritten numbers, if for no other reason than just the graininess of the images. So how did your model perform? And what parameters did you end up using to achieve that accuracy? Let me know below in the comments. You can find the code that I used to train this model and generate these images also in the links below, along with more links to the other resources we talked about in this episode. Our next set of videos will be focused on some of the tools of the machine learning ecosystem to help you build out your workflow and toolchain, as well as showcase even more architectures that you can employ to solve your machine learning problems. I look forward to seeing you there. And until then, keep on machine learning. Thanks for watching this episode of Cloud AI Adventures. Be sure to subscribe to the channel to catch future episodes right when they come out.